This is another example of the applied coordinate geometry. We are working with quadrilaterals. Right, if we now first look at what is given, you can clearly see that it is a quadrilateral A, B, C, D. Okay, they are giving you the following information. The line AB is y equals 2x plus 4, right? Then they also give you coordinate C, which is 16, 11. And then they're also telling you that line AD and AB are perpendicular, and line AB and BC are perpendicular. I want you to realize here, people, that you do not have the values on the x and y axis. Okay? So really, you can't read off the different coordinates. Okay? You know that this one is 16, 11, but A, B, and D cannot be read off from that. All right. So now let's go and look at the questions. The first question is you must find the coordinate A and the coordinate D. Right. Please look at your drawing. What is important for you to realize that coordinate A, people, lies on the y-axis. Okay. And on the y-axis, the x is always 0. Right? So for this one, we have the x coordinate, but we don't have the y coordinate. We don't know that one. So this is the first thing that you must realize, that for A, you already got the x coordinate. A is also a point on the line y equals 2x plus 4, which means you can just simply put the x, which is 0, into the x there. So you take your equation y equals 2x plus 4 and you substitute your 0 into the x, okay? And then calculate for that your y. So the coordinate A is 0, 4 that you have worked out. So now go back to your drawing. I'm just going to rewrite this now. It's no more unknown. As soon as you have an answer, put that into your drawing. So A is 0, 4. Now you must find D. Now for D, you must also realize it is lying on the x-axis. And where it is lying on the x-axis, people, your x value is unknown, but your y value is 0. So you have to realize that for point D, you have no x value, but you have 0 as a y value. But now also important, you don't have this equation, so you can't solve it as you solved A. But what we do know is that AD is perpendicular to y equals 2x plus 4, which means this gradient here for AD, people, the gradient for AD is the reciprocal of that gradient. So it means it's 1/2, okay, with opposite sign. That one is positive, so this one is negative. So because line AB is perpendicular to line AD, you must realize that the gradient for AD is negative 1/2. Okay? It goes back to the fact that when you multiply the gradients of perpendicular lines, you will get an answer of negative 1. And that then, if you have here the gradient of 2, then you must multiply with the reciprocal. So the reciprocal of 2 is 1/2, okay, of the opposite sign. This one is positive, so that one must be negative. That's how we got the negative 1/2. But then if you also realize here, people, that the y-intercept, so the value of C for line AD is at 4. So you basically now have the equation for line AD, which is y equals negative 1/2 x plus 4. This is the y-intercept, people. So you can read off the y-intercept from your previous point that you calculated, calculated A, no? The y value for A. Okay, so you have got the equation. So really, you should write this in here. Y equals negative 1/2 x plus 4. That is how you get the equation for AD. And then because you've got this value 0, which is the y value, you can substitute that into the place of y. Okay, and then you can just simply do Goros OO, which then gives you a value for x of 8. So coordinate D is 8, 0. Okay, I hope you understand that. I will repeat, you must realize that point D is x0. You must also realize because line AB is perpendicular to line AD, that you can get its gradient of negative 1/2. Okay, plus you must also realize that the y-intercept for line AD is 4. So you must realize that the value for C is 4. Okay, and that's how you get the equation. Then you just simply substitute the value of 0 for y, and then you calculate the x. Okay, if we look at the next question, they are asking you the equation of line BC. Okay, the equation of line BC. Now, number one, what you must also realize now is because AB is perpendicular to BC, the gradient for BC is also negative 1/2. It is the same as this above, okay? So here you must realize that the gradient is negative 1/2. Okay, so you can now substitute your gradient into your formula, y equals mx plus c, all right? You have got the gradient. That is step one, as we usually do, substitute the gradient, okay? Then you also have point C. So you've got a coordinate, which means you are now going to substitute the y value and the x value for you to calculate C. And if you do this calculation, you find that C is 19.